Hello everyone, welcome to BYJU'S Exam Prep, most comprehensive app for all exams. How are you guys? Now it is the second session for what network theory, that is part 2. And this is important session for coming exam like what BARC and HAL 2022. Right? Already countdown is started for these exams. Are you ready for these exams? Yes, please. And first of all, inform me that sound quality, picture quality, everything is fine. Yes, please. Please inform me that sound quality, picture quality, everything is fine. Please join the session. Now, this is a very important session for you, and I'm going to discuss what some important numericals on transient and what steady state analysis of sinusoidal signal, that is what resonance. Okay, these two topics are very important. We are going to discuss some questions on first order circuit and some questions on what initial conditions. Right, so inform me that sound quality, picture quality, everything is fine. Yes, please. Yes, everyone, please inform me that sound quality, picture quality, everything is fine. Okay, clear. बहुत बढ़िया. चलिए अब देखते हैं जरा 1 मिनट. अब आ जाते हैं. This is a BARC and HAL 2022 network theory part 2. Right, already in part 1 we have discussed what theorems and basics of what network, like what KCL, KVL, supernodal analysis, some important numericals on what Thevenin's theorem, Norton's theorem, one question on superposition theorem, maximum power transfer theorem, Millman's theorem, Telegan's theorem. Okay, in first session, in first part, and now it is a second part, that is a network theory. So this is my introduction. Myself Sanjay Rathi, 20 plus years of teaching experience in the field of competitive exams like ECE, GATE and PSU. Okay, and I have qualified and selected for engineering services exam. These are my ranks: AIR 16 in ECE 2005 and AIR 21 in ECE 2008. And I have mentored more than 1 lakh students for these exams. So my dear students, first of all, press the like button, right? Share the link of this session so that the student will join and subscribe our channel, because we have number of important session for you. And that is one session by Rakesh Talreja sir and Asutosh Saxena sir. How to start preparation for GATE 2023 and 24. How many students are interested for this? 23 and 24. Long term plan, that is what 24. And next year, that is what GATE 2023. Because this is very important. Now here Rakesh sir and Asutosh sir will discuss what strategy, what should be the strategy, right time to start, tips and tricks, each and everything, and that is the session for you. Okay, so please subscribe the channel. Now very simple thing, we will start with what transient. Try to give me the answer for this question. What is the answer for this question? With this question I am going to give you the idea about first order RC circuit. Simple RC circuit. This is very important topic for any type of competitive exams, right? Especially for coming exam, that is BARC and HAL. Okay, so everyone, what will be the answer? The capacitor of the figure shown below. The capacitor of the figure shown below has 25 volt on it with polarity shown at the time the switch is closed. The expression for VC is, what will be the expression for VC? That is the 40 volt, 200 ohm, 1000 microfarad, and that is the answer given, right? So everyone, please give me the answer. What will be the answer for this question? Okay, बताइए जरा क्या आंसर होगा? Give me 1 minute. Okay, Asutosh Samal is giving the answer A, right? Now this is a simple RC circuit, right? First of all, always remember capacitor of the figure shown below has the 25 volt on it. Always remember capacitor does not allow sudden change of voltage. Means what is the meaning? VC 0 negative is equal to what? VC 0 positive is equal to what? 25 volt. but we have one exceptional case. Capacitor will allow sudden change of voltage. Please give me the comments, right? For impulsive current or for impulsive voltage? Right. Please give me the answer. Capacitor allow the sudden change of voltage, right? For impulsive current or impulsive voltage? ये भी एक क्वेश्चन है भाई. For impulsive voltage or for impulsive current, capacitor will allow the sudden change of what? Voltage. What is the voltage across the capacitor? That is the Q by C, that is 1 by C integral of I dt. Right? So normally the capacitor does not allow the sudden change of voltage. First of all, I will solve this question, then give me the answer for this particular question. Okay. Right? What is the initial voltage given? 25 volt. Right? Already it is charged by what? 25 volt. Now, what will be the expression? What will be the expression? Simply always remember, new students, the formula VCT. This is the function of time. That is given by V final, that at t equal to infinite, minus V final minus V0 e raised to power minus t by tau. V0 means what? Initial value, initial voltage across the capacitor, right? And what is the meaning of the V infinite? At t equal to infinite, what will be the value? Right? These are the two values. Some students remember this formula: V infinite plus V0 minus V infinite e raised to power minus t by tau. It doesn't matter, so simply take minus outside this bracket and you will get this answer. T by tau. What is the tau? RC, time constant. 200 into, that is 1000 microfarad. 1000 into what? 10 to the power minus 6. This is the 1000 microfarad. So 1, 2, 3, 4, 5, and you will get the 0.2 second. Always remember, we are calculating the time constant for what? T greater than 0, right? So that is the time constant, 0.2 second. And then what is the final value? Finally, always remember, for DC transient, this is the DC. For DC transient, capacitor act as open circuit. At steady state, capacitor act as open circuit. So what is the voltage across the capacitor? Finally, 40 volt. And what will be the current? 0. And that's why it is called open circuit. This is the R. We have the final voltage, we have the initial voltage, we have the formula, so that will become VCT is equal to V final. What is the V final? 40 minus 40 minus 20, that is 25 e raised to power minus t by 0.2, and that will become 40 minus 15 e raised to power minus 5t. Right? And that is valid for what? T greater than 0. That is valid for t greater than 0. So that is the answer. 40 minus 15 e raised to power minus 5t. Okay. So what is the answer for that question? Yes, everyone. When the capacitor will allow the sudden change of voltage, so sudden change of voltage for impulsive current or impulsive voltage, that is the answer is correct. Impulsive current. Only one student give the answer, Ankit Yadav. Yes, you are correct. For impulsive current, for infinite current, capacitor will allow sudden change of what? Voltage. Normal case में वो कभी भी allow नहीं करेगा, but for impulsive current it will allow the sudden change of voltage. तो ये हो गया इसका concept. अब भाई जरा एक बार अपने ग्रुप में शेयर कर लीजिएगा लिंक को. अब आते हैं दूसरे क्वेश्चन में. बताइए what will be the answer for this question? For the circuit of the figure, this is visible to you. 10 ampere source है, 1 ohm resistor, switch, 3 ohm resistor, 5 Henry inductor. This is the 5 Henry inductor. For the circuit of the figure, the inductor current IL just before t equal to 0 is. Just before t equal to 0 is. अगर यहाँ पर for the circuit of the figure, inductor current IL just before the t equal to 0. मतलब आपका switching close होने से पहले what will be the current through the inductor? Inductor does not allow sudden change of what? Current. Please give me the answer. A, B, C or D. Take your time. This is a 10 ampere current source, 1 ohm resistor. Initially the switch is open. Now it will be closed at t equal to 0. This is the 3 ohm resistor and that is the 5 Henry resistor. Okay. अब देखिए, new students always remember, when we are talking that let this is the t equal to 0 at which the switch is closed. So normally we are getting the transient. Normally we are getting the transient. 1 minute. 1 minute. 1 minute. There is some technical issue. Yes. Now. That exactly at t equal to 0, there will be a switch may be closed or may be open, and that's why transient. That is the reason for what transient. There is a change in the circuit. So just before means at this point, 0 negative. After means at d point, 0 positive. At this point, the circuit is in steady state. Circuit is in steady state. And for steady state, capacitor act as open circuit and inductor act as what? Short circuit. This point is called initial condition. This point is called initial condition. And at this point at t equal to infinite, again circuit reached to what? Steady state. Again capacitor act as open circuit, inductor act as what? Short circuit. Remember this point. And that is for t less than 0 means this is the t less than 0. This is the position. So always remember at t equal to 0 negative, for DC the circuit will be in steady state. So what is the condition? Inductor will act as what? Short circuit. When the inductor will act as short circuit, which is open, simply current division rule. Simply current division rule. IL0 negative is equal to IL0 positive is equal to 10 divided by 1 plus 3 into what? 1. And that will become what? 2.5 ampere. 2.5 ampere will be the current. बिल्कुल सही आपने अंकित चौहान, अंकित यादव, विपुल कुमार, अरे ये आप राइट, ऋतिक, जितने लोगों ने भी बताया, आशुतोष, आपका आंसर बिल्कुल सही है. ये देखिए, ये हो गया आपका 2.5 एम्पियर. नाउ व्हाट विल बी द नेक्स्ट क्वेश्चन? व्हाट इज द टाइम कांस्टेंट ऑफ द सर्किट? एवरीवन प्लीज गिव मी द आंसर. व्हाट विल बी द टाइम कांस्टेंट ऑफ द सर्किट? ऐसा दैट नेक्स्ट क्वेश्चन में बी व्हाट विल बी द टाइम कांस्टेंट ऑफ द सर्किट? क्या होना चाहिए भाई टाइम कांस्टेंट ऑफ द सर्किट? बताइए जरा. यस, the time constant of the circuit. Always remember we are calculating the time constant after closing the switch. When after closing the switch, this path will act as short circuit, the complete current will pass through this and the inductor will discharge through what? 3 ohm resistor. Inductor will discharge through 3 ohm resistor. Then what will be the time constant? Then simply always remember, for t greater than 0, that switch is closed. This is the 3 ohm, this is the inductor, and this is the 5 Henry. And what will be the path? This is the path of the current. Then what is the time constant of the circuit? Tau is equal to L by R. That is nothing but 5 by 3. 5 by 3 second. Okay, that is 1.67 second. That will be the answer for this circuit. बिल्कुल सही है, 5 by 3 second, right? And sometimes they may ask, what will be the current in this branch? What will be the current in this branch in a downward direction? What will be the current? What is the equation of the current in downward direction? Right? Okay, they may ask what will be the current. Yes, Surjit Das, how are you? Vipul Kumar. Dekho, 10 ampere current. Once the switch is closed, the voltage across this 1 ohm resistor is 0, and that's why what will be the current? 0. For t greater than 0, the current through this is 0. The 10 ampere is here, right? And here it is a IL. So what is this? Minus IL. What is the value of I? I will become 10 minus IL. 10 minus IL. Right? And we have initial current, we have final current. What will be the final current through the inductor? 0. What will be the time constant? What will be the time constant of the circuit? 5 by 3. Because that is the equation. That is the equation 10 minus IL. This is the 10, this is IL. So I can write 10 is equal to 10 minus I final that is the inductor current, minus I initial e raised to power minus t by tau. So what is this? 10. What is the final value of the current? 0. What is the final value of the current? 0. What is the initial value of the current? Already we have calculated 2.5. This is the initial current through the inductor. E raised to power minus t, that is the 5, tau is the 5 by 3, so it will become 3 by 5 tau t. Now you can calculate the value. You can calculate the value. That answer is what? 10 minus 2 point, right? This is the minus, that is the minus, minus, this is the minus, minus, plus, again it is the minus, and you will get the answer. 10 minus 2.5 e raised to power minus 3 by 5 t. Are you getting me? Are you getting me? One student give the answer, yes, 10 minus, Ankit Yadav bilkul sahi hai, 10 minus 2.5 e raised to power minus t by tau, and tau is the value, that is the 5 by 3. So we are having the short circuit path. No, no, this is the short circuit path, but we are having the 10 ampere. Here it is the IL. What is in? Minus IL, and what is the total? I is equal to 10 minus IL. It is exponentially decreasing function. Right, it is a exponentially decreasing function, right? Current through the inductor. Okay then. Next one. With multiple questions on single diagram. Now what is the answer for this question? For the circuit shown in the figure, find the frequency at which this circuit will be at resonance. This circuit will be at resonance. Kya hona chahiye? What should be the frequency so that this circuit will be in resonance? 1 j omega minus j 2 ohm, 1 ohm resistor, right? 1 by, this is minus j by 2 omega. This is nothing but capacitor, 1 ohm, this is the j omega, right? What is the answer? So please everyone. So in this question, simply always remember, new students, what is the meaning of the resonance? First, practically, what is the meaning of the resonance? Applied voltage and resultant current. Applied voltage and resultant current should be in same phase, right? So applied voltage is here and the resultant current is here. This should be in same phase. Then it is possible when the angle of the impedance, or if we are having the impedance R plus jx, then the imaginary part of the impedance should be equal to what? 0. If the imaginary part of the impedance is 0, means impedance is what? Purely resistive. And if the impedance is purely resistive, then current and voltage will be in the same phase. Current and voltage will be in the same phase. Now, very simple. Calculate the Z in. What is the Z in? Z in is equal to, watch this carefully, this is the j omega plus these two impedances are in parallel, so we can write 1 minus j by 2 omega upon 1 minus j by 2 omega. Because these two are in parallel, we can write it like this, j omega plus omega, 2 omega cancel, and this will become minus j by what? To multiply it by 2 omega minus j, right? Now please multiply it. This will become j omega square, j 2 omega square, j, this is the minus 1, this will become plus omega, right? Minus j divided by 2 omega minus j. Multiply 2 omega minus j upon 2 omega minus plus j. Plus j. Now simply watch this. We want only imaginary term. We want only imaginary term. So imaginary term should be equal to 0. Now denominator is what? Normal real term. Now when this 2 omega is multiplied with this, we are getting the imaginary term. So what is the imaginary term? 4 omega cube. When this is multiplied with the 2 omega, 4 omega cube. When this 2 omega is multiplied with this one, no imaginary term. Minus 2 omega. That is the imaginary term. Now when this j is multiplied with this, there will be the imaginary term plus j omega. So already j is common. This is the omega. and this imaginary term should be equal to what? 0. From this you will get the omega is equal to 1 by what? 2. 0.5 radian per second. 0.5 radian per second. So no need to calculate the real part, only focus on what? Imaginary part and equate it to what? 0, and so that you will get the answer for this question. तो ये आ गया आपका resonance, that is the 0.5 radian per second. Now we have number of questions on what? Resonance. Number of questions for resonance means what? Series resonance and parallel resonance. So remember this, I am giving you just a similar formula. If it is in series, that this is called series resonance. R, L and C are in series. Then at resonance, voltage and current will be in the same phase. Voltage across the resistor is VR, voltage across the inductor is VL, voltage across the capacitor is what? VC, right? And the magnitude of VL is exactly equal to what? Magnitude of VC. And they will cancel each other, and therefore the combination of inductor and capacitor will act as, give me the answer. At a series resonance, series combination of L and C will act as open circuit, short circuit, inductive impedance or capacitive impedance. Everyone, combination of L and C will act as open circuit, B short circuit, inductive in nature and capacitive in nature. Everyone, कैसा बिहेव करेगा भाई? क्या हो गया? आप लोग बताइए जरा फास्ट, गिव मी द कमेंट्स. कैसा बिहेव करना चाहिए? व्हाट विल बी द सीरीज कॉम्बिनेशन ऑफ इंडक्टर एंड कैपेसिटर? इट शुड एक्ट एज व्हाट? ओपन सर्किट, शॉर्ट सर्किट, इंडक्टिव और व्हाट? कैपेसिटिव, राइट? आशुतोष कमाल बोल रहे हैं कि ये शॉर्ट सर्किट जैसा बिहेव कर रहा है. दिस विल बिहेव लाइक व्हाट? शॉर्ट सर्किट. यस, इन सीरीज रेजोनेंस द कॉम्बिनेशन ऑफ इंडक्टर एंड कैपेसिटर विल एक्ट एज व्हाट? शॉर्ट सर्किट. And that's why the complete voltage will be across what? VR, right? Complete voltage will be across what? VR. Yes, Richa Bhavani, how are you? And that is the B answer, that is the short circuit. बिल्कुल सही. चलिए अब आते हैं दूसरे क्वेश्चन में. चलिए इसका आंसर बहुत तेजी से आप लोग बता दीजिए. The switch in the figure has been closed for long time, right? स्विच को हमने क्लोज कर दिया for long time के लिए. अब बताइए जरा, एंड इट इज ओपन एट t इक्वल टू 0. अब आपने एग्जैक्टली एट t इक्वल टू 0 स्विच को ओपन भी कर दिया. दिस इज द 1 ohm रजिस्टर, 9 ohm, दैट इज द 20 millifarad, 3 ohm. एग्जैक्टली एट t इक्वल टू 0 स्विच इज ओपन. फाइंड Vt फॉर t greater than 0. व्हाट विल बी द इक्वेशन? दैट इज अ वेरी वेरी इजी क्वेश्चन. एंड द इनिशियल एनर्जी स्टोर्ड इन द कैपेसिटर. व्हाट विल बी द इनिशियल एनर्जी स्टोर्ड इन द कैपेसिटर? Right, net reactive portion is 0, so yes, we can say that is the impedance part, and that's why the combination will act as what? Short circuit, definitely. Okay, Surjit, अब बताओ इसका क्या होगा आंसर? तो right, that is the 20 volt battery. Always remember, this is the 20 volt battery. This is the 9 ohm, this is the 1 ohm, and then what will be the energy? Half of CV square and so on. You can calculate like this, right? तो चलिए बताइए भाई. ऑप्शन ए 15 e raised to power minus 5t 2.25 जूल, 20 e raised to power minus 1.75 जूल, 15, और अगर इसमें से कोई और ऐसा लगता है नॉन ऑफ दिस, तो यू आप बोल सकते हैं नॉन ऑफ दिस. चलिए बताइए जरा, व्हाट विल बी द आंसर? विपुल कुमार इज गिविंग आंसर ए, ऋतिक गुंजन इज गिविंग सी. ए और सी, यू आर कंफ्यूजन. ओह, time constant is different. Please watch here, it is the time constant difference, minus 5t minus 10t. चलिए देखते हैं जरा. अब देखो, now always remember at t equal to 0 negative, switch was closed, was closed. Capacitor under steady state will act as open circuit. Thus there is no current across the capacitor. Under steady state there will be a no current. Exactly at t equal to 0 negative, always remember the circuit will be in what? Steady state. So Ankit Yadav is giving the answer A, Ritik Gunjan, Chinmay Roy is giving the answer C. So read question carefully. This is the minus 10t, this is the minus 5t, that is the difference. Okay, no problem. Now So this will act as open circuit. So there will be a no current. So what will be the voltage across the 9 ohm resistor? That is called VC0 negative is equal to VC0 positive is equal to 20 into 9, voltage division rule, 3 plus 9. And that will give the 15 volt. This is the initial voltage across the capacitor. Second thing, what is the energy, initial energy? That is given by W, half of CV square. 1 by 2 into 20 millifarad into 10 raised to power minus 3 into 15 square. Solve it, you will get the 2.25 joule. That is the initial energy. Now, what will be the time constant of the circuit? When we are calculating the time constant, my dear, this switch is open. When this switch is opened circuit, remove this. We have to calculate the time constant of this circuit only. We have this circuit only because this switch is opened. 1, 9, 20 millifarad. What is the time constant, RC? 9 into, that is the 10 into 20 into 10 raised to power minus 3, that is nothing but 0.2 second. 0.2 second. What is the formula? Because it is a source free circuit, that's why the final value is 0. You can directly write initial value e raised to power minus t by tau. What is the initial value? 15 e raised to power minus t by 0.2, and you will get the 15 e raised to power minus 5t. 15 e raised to power minus 5t. Chinmay, Ritik, that is clear to you everyone? तो ये आपका आंसर आ रहा है ए. इन दोनों में एक ही डिफरेंस था. यहाँ पर देखिए ये 15 e raised to power minus 10t है. 15 e raised to power minus 5t. That will be the time constant. Okay then. कितने स्टूडेंट्स इसे सॉल्व कर लेंगे भाई, ये बताइए जरा. ओके, ये आ गया आपका क्वेश्चन. तो चाहे ये दैट इज इंपॉर्टेंट क्वेश्चन. व्हाट इज द इनिशियल एनर्जी एंड व्हाट विल बी द फॉर्मूला, व्हाट विल बी द टाइम कांस्टेंट. नाउ एक बढ़िया क्वेश्चन आप बनाइए जरा. दिस इज वेरी वेरी इंपॉर्टेंट वन. राइट, that is on what initial condition. Initial condition, that is the second order circuit. But in second order circuit, no one is going to ask what, find the equation, because it will become very lengthy question, right? We can't find the equation. In first order circuit, it is possible to find the equation, like first question, what is the equation? Like last question, what is the equation? But in second order question, normally they will ask what, initial conditions. What are the initial conditions? Or in series RLC circuit or parallel RLC, they will ask what is the under-damped response, what is the over-damped response, what is the critically damped response, what are the conditions for over-damped, critically damped and under-damped in case of series RLC circuit or in case of what, parallel RLC circuit. वहाँ से आएगा transient. यहाँ पर है initial condition. Watch this. In the circuit, calculate the dVR by dt 0 plus. dVR by dt 0 plus. You have to calculate. This is the 3 ut, right? Normally, what will be the question? IL 0 positive. That is the question. DIL by dt 0 positive normally, or what, voltage across the capacitor, or dVC by dt 0 plus. But in this question, what is asked here? dVR by dt 0 plus. dVR by dt 0 plus. Initial condition. 2 ohm resistor, this is the VR, voltage across the resistor. 1 by 2 farad, that is the VC. 20 volt battery, 0.6 Henry, 4 ohm. Now, always remember, capacitor does not allow sudden change of voltage. Capacitor, oh, Asutosh is giving the answer D. Okay, chalo check karte hain. Capacitor does not allow sudden change of voltage. Inductor does not allow sudden change of current. Yahan, what is there? There is no switch. But what is this? 3 ut. What is the meaning of the 3 ut, everyone? 3 ut means this is the 3 ampere current for t greater than 0, and this is the 0 ampere for t less than 0. So that is the switch. That is the switch. When the current is 0, it will act as what? Open circuit. And then first of all, exactly at t equal to 0 negative, circuit is in steady state. circuit is in steady state. This is a very conceptual question. With these questions you are going to get what idea about what initial condition. The circuit is in steady state at 0 negative, and this portion will act as what? Open circuit. So please remove this. This portion will act as open circuit. To remove this current source. Now capacitor will act as what? Open circuit. This is the open. So what will be the voltage? Write down this. There is no current. What is the current through the inductor? 0. Right. IL0 positive is also 0, because inductor does not allow sudden change of current. Right. No need to calculate the initial voltage across the resistor, because it will allow the sudden change of voltage as well as sudden change of current. Now this is the reference. Write down the KVL from this point to this point. Vc plus 20 is equal to 0. So what is the Vc 0 negative is equal to Vc 0 positive is equal to what? Minus 20 volt. The initial voltage across the capacitor is what? Minus 20 volt. They may ask, what is the answer? Minus 20 volt. What is the initial current through the inductor? 0. Right. Now we have to calculate initial dVR by dt. My dear friend, again, for take 0 plus, this 3 ampere current source is connected here, because it is a unit step function. This is the 3 ampere current. Now capacitor does not allow sudden change of what? Voltage. Clear? What is the inductor? Inductor does not allow sudden change of current. So initial current is through the inductor is 0. Initial voltage across the voltage will remain same, that is the Vc 0 plus is equal to what? 20 volt. Initial current through the inductor will remain same, that is the 0 ampere. No current will flow. Now we have to find the VR. So what is the incoming current? 3. What is the voltage at this point? What is the general formula of the voltage? So I can write Vc plus 20 volt. What is the voltage at this point? Vc plus 20 volt. Now write down the KCL at this point. Write down the KCL at this point. This is the VR. So we can write what is the incoming current? 3. What is the outgoing current? VR by 2. What is the outgoing current? VR minus Vc plus 20 divided by what? 4. Divided by 4. Right. That is the value. From this you can take the LCM 4. It will become 12 is equal to VR. Right. This is the VR. Sorry. This is the VR. VR minus Vc by 20. So this is the VR. And this will become 2 VR, because I am taking the 4 as a LCM, plus VR minus Vc minus 20. Minus Vc minus 20. Then you can write it like this. 12, 32. 12 plus 20, that is the 32. 3 VR minus what? Vc. That is the equation. That is the equation. Why this equation is important? Okay, Saloni, how are you? Why this equation is important? Because we can get the dVR by dt from this equation. That's why I am writing this equation. dVR by dt means if you want to calculate the initial voltage across the resistor, you can also calculate. What is the V0 plus? From this equation, that is nothing but 32 plus Vc divided by 3. What is the initial voltage across the capacitor? Minus 20 volt. So 32 minus 20 divided by 3, that is nothing but 4 volt. What is the initial voltage across the resistor? 4 volt. So this is the 4 volt we can calculate. What is the initial current through the resistor? 4 divided by 2. What is the current here, my dear friends? 4 divided by 2, that is the current is 2 ampere. Now this is the 3 ampere current. So what is the current here? 1 ampere. What is the initial current through the inductor? 0, and that's why this 1 ampere current will flow through the capacitor. 1 ampere is the current, initial current through the capacitor. Why I am calculating the initial current through the capacitor? Because when I am differentiating it, what will become? 0. 3 dVR by dt minus dVc by dt. What is the dVR by dt? dVR by dt is nothing but 1 by 3 times of what? dVc by dt. 1 by 3 times of what? dVc by dt. But we are not having the value of the dVc by dt. but we have the initial current through the capacitor. The initial current through the resistor is 2 ampere, initial current through the capacitor is 1 ampere, and that's why we can calculate what is the initial current through the capacitor is given by C dVc by dt. So what is the initial dVc by dt? 0 plus, it is nothing but I0 plus divided by C, and this is 1 divided by 1 by 2, that is, because 1 by 2 farad is the value, this will become 2 volt per second. What is the dVr by dt 0 plus? That is the answer, 1 by 3 of this, so 2 by 3. 2 by 3 volt per second. This is a very conceptual questions, right? आप क्या बोलेंगे इस क्वेश्चन के बारे में? यस, आपके क्या कमेंट्स है भाई? तो आपका जो आंसर है वो है 2 by 3. 2 by 3 means what? 1.667. 1.667 volt per second. देखो, from one question we are getting the number of information, right? One question, yes. Capacitor will allow the sudden change of current, but it does not allow sudden change of what? Voltage. Capacitor allow the sudden change of current, but it does not allow sudden change of voltage. Always remember, this is a switch. Initially it is open. Initial voltage across the capacitor is minus 20 volt. Initial current through the inductor is 0. Inductor does not allow sudden change of current. Capacitor does not allow sudden change of voltage. Resistor allows sudden change of current as well as sudden change of voltage. So no need to calculate this value. Second thing, right, find the value, initial value. No need to find the voltage across this. Simply find the current, that is the 0. Then exactly we write down the KCL at this point. VR plus VC plus 20. VR, देखिए, what is the incoming current? 3. VR by 2. That is VR minus VC and so on. We are getting one equation. Since we have the initial value of the VC, you can find the initial voltage across the resistor. Find the initial voltage across the resistor. That is what? 4 volt. Once you will get the initial voltage, you can calculate the initial current. 2 ampere here. What is the 1 ampere and what is the current here? 1 ampere. And then from this we can find the dVc by dt. They may ask what is the value of the dVc by dt 0 plus. We can find, right? Second thing, what is the answer? dVr by dt. Please differentiate it and put the value of dVc by dt. You will get the answer. So that is the method. Ultimate question is what? dVr by dt. देखिए, थोड़ा टफ आएगा तो सब गायब हो जाएंगे. ये अब ये देखिए आप लोगों के लिए बहुत ही जो सिंपल सा क्वेश्चन है. व्हाट इज द आंसर फॉर दिस क्वेश्चन? व्हाट इज द आंसर फॉर दिस क्वेश्चन? यस एवरीवन. इन द सर्किट गिवन बिलो द स्विच इज ओपन फॉर अ लॉन्ग टाइम. In the circuit given below, the switch is open for a long time. At a time t equal to 0, the switch is closed. What are the initial and final values of the voltage across the inductor? Again, question on what? Initial and final value. What will be the initial and final value, everyone? 1, 8, 1, 50 millihenry. Switch was open. Now exactly at t equal to 0, it is closed. Then what will be the voltage across? Initial voltage across the inductor and capacitor. That is the question. भाई एक बार जरा इसे शेयर कर लीजिएगा. अब देखते हैं क्या होगा आंसर इसका. तो आंसर दिया हुआ है 0 वोल्ट 0 वोल्ट 0 वोल्ट 80 वोल्ट 80 वोल्ट 0 वोल्ट 80 वोल्ट 80 वोल्ट. राइट. देन exactly at t equal to 0, the switch is open. Inductor will act as what? Short circuit. What will be the current through the inductor? Because inductor does not allow sudden change of what? Current. Inductor will act as short circuit. 1, 8, 1. This is the 100 volt. So what is the initial current? 100 by 10, that is what? 10 ampere. 10 ampere will be the current. Okay. Now does not allow sudden change. Now the switch is closed, and that's why this path will act as short circuit. We are having only 2 resistors and 1 inductor. That is the position. That is the position exactly at t equal to 0 plus. Current will remain 10 ampere. This is a 100 volt. My dear friends, this is the 1 ohm, this is the 1 ohm. So what is the drop across this? 10 volt. What is the drop across this? 10 volt. So what is the drop across the inductor? 20 volt. Sorry, 80 volt. 80 volt. ये देखिए 80 volt. Okay. Now, Asutosh, you are giving the answer C. Yes. 80 volt is the initial voltage. And exactly at t equal to infinite, again inductor will act as what? Short circuit. Again the inductor will act as short circuit. So what is the final voltage across the inductor? 0. The final voltage across the inductor is 0 at t equal to infinite. देखिए 80 volt and 0 volt respectively. थोड़ा क्वेश्चन ढंग से पूछ लेना. What are the initial and final values of the voltage across the inductor? This is the initial voltage, that is the final voltage. So normally we are calculating what? Current through the inductor, but this time we have to calculate voltage across the inductor. Voltage across the inductor, final and initial value. Right? Always remember, if we have the initial voltage across the inductor, then you can calculate the di by dt, because L di by dt 0 plus is nothing but VL 0 plus. From this you can calculate the di by dt 0 plus is nothing but VL 0 plus divided by value of the inductor. We have the value 80 divided by 50 millihenry, you will get the di by dt 0 plus. That will be the objective question. Without calculator you can solve. Without calculator you can solve. This type of questions on initial condition. Now, what is the answer for this question? Please tell me. Yes. Again, this is a very, very easy question. Within 10 seconds you can give the answer for this question. The circuit shown below is under steady state. With the switch closed, the switch is opened at t equal to 0. What is the time constant of the circuit? What is the time constant of the circuit? Everyone. The circuit shown below is under steady state. With the switch closed, the switch is opened at t equal to 0. What is the time constant of the circuit? Always remember, we are calculating the time constant for t greater than 0. Once the switch is closed, now this 10 volt battery is removed from the diagram. This is a 2 Henry inductor, this is the 10 ohm resistor. What will be the time constant? Time constant is nothing but L by R. Time constant is nothing but L by R. What is the L2? What is the 10.2 seconds? 0.2 seconds. Okay. तो यहाँ पर ध्यान दीजिएगा. When the circuit shown below, the switch is closed. What is the switch is opened or closed? Opened. जैसे ही आपने open किया, we have this circuit only. For this circuit, what is the time constant? L by R. That is what? 0.2 seconds. So B is the correct one. बिल्कुल सही आपने बताया आशुतोष. Utkarsh, you are giving the answer A. That is not by 0.1 नहीं है. The value of this is 2 Henry and that value of this is 10 Henry. 2 divided by 10. Okay, remember this. Now, what is the answer for this question? Yes, Utkarsh, why you are giving the answer that is 0.1? What is the reason? क्या है भाई, क्यों आ रहा है आपका आंसर? चलेगा, आप बता सकते हो कॉन्सेप्ट. Now, parallel RLC circuit shown in the figure is in resonance in this circuit. Resonance. This circuit is in resonance. This is a 1 milliampere. It is the RMS value. R is given, L is given, C is given. Current through the resistor is given IR, IL and IC. What is the relation? Parallel RLC circuit shown in the figure is in resonance. IR less than 1 milliampere. IR plus IL greater than 1 milliampere. IR plus IC less than 1 milliampere. IL plus IC greater than 1 milliampere. That is the magnitude of these two current is greater than 1 milliampere. Now, which one is the correct one? Ritik Gunjan, you are giving the answer B for this. Okay. So, if the circuit is in resonance, always remember this current and applied voltage. This is the voltage. Will be in the same phase. Will be in the same phase. Then we can draw a phasor here. We can draw a phasor. Watch this one. right? Now watch this diagram. Always remember that this is the VR, then this is the IR. IR in the same phase, ये देखिए, this is the IR and this is the VI. VI and IR in the same phase. Now what is the inductor current? Inductor current will lag behind the voltage. Lag behind the voltage, IL. And what is the capacitor current? Lead the voltage by 90 degree. This is the IC. In a resonance, the magnitude of IC is exactly equal to what magnitude of IL. But actually it is on imaginary axis, negative imaginary axis, it is on positive imaginary axis. That's why they will cancel each other. So one answer is, sir, IR is less than 1 milliampere. Wrong, because in resonance this will act as what? Combination will act as open circuit. The complete current will pass through resistor R, and that's why the magnitude of IR is exactly equal to what? 1 milliampere. That's why this answer is wrong. IR plus IL greater than 1 milliampere. Yes, that is correct. Why? IR plus IL. What is the resultant? Resultant is, this is the resultant. Right? Resultant, simply that is the resultant. Yes, this resultant is greater than what? 1 milliampere. Definitely it will be greater than 1 milliampere, and that's why that is correct. IR plus IC less than 1 milliampere. No, it is also greater than 1 milliampere. Similar reason, this is also greater than 1 milliampere. Right? It is also greater than 1 milliampere. IL plus IC greater than 1 milliampere. They will cancel each other. That is the zero. The magnitude of IL and IC is what? Equal to 0, and that's why this is also wrong. Chinmay, now it is clear to you, everyone? Where is the dependent variable? In which case the dependent variable? ये 0.5 वोल्ट लिखा हुआ है मेरे भाई, कहाँ पर डिपेंडेंट है? अच्छा, अगर आप इसको ले रहे हो, चलिए ये भी बात ठीक है. देखो मैं आपको बता रहा हूँ. ओके, दैट इज द रीजन. ओके, हाँ, ये चिन्मय आपने बोला, मैंने इसे कंसीडर कर लिया 0.5 क्योंकि मेरे पास डेटा ये था और मैंने यहाँ पर बता दिया था V वोल्ट. अब चलो मैं आपको बता देता हूँ डिपेंडेंट सोर्स अगर है तो कैसे हैंडल करना है. राइट, चलिए कोई बात नहीं. इफ वी आर हैविंग द डिपेंडेंट सोर्स हियर, सपोज मैंने यार देखो यहाँ पर क्या होता है, नेटवर्क में नॉर्मली डिपेंडेंट सोर्स का सिंबल ऐसे देगा. कोई बात नहीं, अगर आप, मैंने उसको एज्यूम किया है और जो मैंने क्वेश्चन दिया उसके हिसाब से मैंने दिया था इंडिपेंडेंट सोर्सेस. If we are assuming it what dependent sources, let this is the, what will be the answer, everyone? What will be the answer for this question? Let, I am giving, this is the V, this is the 10 ohm, and this is the inductor. Now exactly at t equal to 0, now watch this diagram. Now this is the switch is opened. This is the 10 ohm resistor and this is the 10 volt battery. Now this is the 10 ohm resistor and that is what 10 ohm. Okay. Now if that is the question, then try to understand this concept. This is the 2 Henry. How we can calculate the Thevenin's L by RTH? L by what? RTH. We are having the voltage V here. Yes, everyone. We are having the, if we are assuming that that is a dependent source, but I have given like what? Independent source. But you can solve like this. If it is a 0.5 volt dependent source, this is depends upon this value, then my dear friends, always remember we have to calculate the RTH across this. How we can calculate? This is the RTH, let this is the value. This is the RTH, let this is the value. First of all, remove it and connect the 1 volt battery. Normally we are connecting the 1 volt battery, but what is the voltage here? V, and that's why this V will become what? 1 volt. And what is the current here? I, and that is the 10 ohm, and this is nothing but 0.5 V. What will be the current? I is equal to V minus, V is the 1 volt, V is the 1 volt, and that's why it will become 0.5 and this will become 1. we can write I is equal to 1 minus 0.5 divided by 10. So that is 0.5 divided by 10. That is the value of I. So what is the value of the resistance RTH? 1 by I. 1 by I, that is the 10 divided by 0.5. This is nothing but 100 divided by 0.5, 20. Am I correct? That is the how we can calculate the value 20. अब आ गया 2 Henry and that is the 20. 2 divided by 20 and that is become what? 0.1. In this case that is the right. But I have given you the question that is what? Independent sources. तो अगर आपने आंसर दिया है that is the correct. If I am giving it that is the dependent sources then it will be the answer is what? बिल्कुल आप उत्कर्ष उस केस में आपका बिल्कुल आंसर सही है, that is the 0.1 Henry. That is the dependent one. Okay. So that is the method how we can calculate. कोई भी source free है, if it is we are having the dependent sources then you can use this method RTH. Always remember the time constant is what? L by RTH, or in case of capacitor it will become RTH into C. RTH into C. Okay then. Next one. Next question. Now it is okay everyone. With dependent 0.1. With independent 0.2. That is the 0.2 second. Now next question. Sir, please start the series for Niled just like what HAL and BARC. Okay, Akhil Tej, we will work on it. तो अभी बात करते हैं उसके बारे में कितनी जल्दी हम लोग ये सीरीज चालू कर सकते हैं फॉर नाइलेट. ओके, चलिए देखते हैं जरा. अब आ जाओ इस क्वेश्चन पर. ये भी हो गया. नाउ ये तो हमने बता दिया क्या होगा. लास्ट क्वेश्चन. If the Q factor of a coil at resonant frequency of 1.5 megahertz is 150 for a series resonant circuit, then the corresponding bandwidth is, what will be the corresponding bandwidth? Tell me what will be the corresponding bandwidth? If the Q factor of a coil at resonant frequency of 1.5 megahertz is 150 for series resonant circuit, then the corresponding bandwidth is. Okay, for series resonant we have the formula bandwidth. What is the relation between bandwidth and resonance frequency? That is omega naught by Q if it is in radian per second, or what? Bandwidth is equal to F naught by Q if it is in hertz. It is in radian per second. Answer is given in hertz and that's why F naught 1.5 megahertz, 1.5 into 10 raised to power 3 kilohertz divided by 150 and you will get the answer 10 kilohertz. 10 kilohertz. So, everyone please revise all this formula because this type of question simply formula based. Series resonance, parallel resonance, quality factor, bandwidth, right? What is the relation between what? Resistor, inductor and capacitor and so on. Just for example, the bandwidth, the formula for the bandwidth is what? R by L. What will be the quality factor? Formula for the quality factor and so on. Okay, please remember this formula. Now, if the switch S in the circuit shown below is opened at t equal to 0, if the switch S in the circuit shown below is opened at t equal to 0, what are the values of V0 plus and dV by dt 0 plus respectively? Yes, please. Okay, क्या होना चाहिए भाई? If the switch S in the circuit shown below is opened at t equal to 0, what are the values of V0 plus and dV by dt 0 plus respectively? देखो, this time normally in case of inductor the question is what? IL and IL 0 plus. IL 0 plus DIL by dt 0 plus. But we are asking about what? V0. This is the inductor 1 Henry. This is the 100 ohm resistor. That is the 1 ampere current source. 1 ampere current source. What will be the answer? Yes, please. क्या होना चाहिए भाई आंसर? चलिए देखते हैं जरा कैसे बना सकते हैं इसको. दैट इज वी आर हैविंग व्हाट एग्जैक्टली एट t equal to 0 the switch is opened, right? So what is the, when the switch is closed, what is the current through the inductor? 0. For t0 negative, switch is closed, the complete current will pass here. What is the initial current through the inductor? Initial current through the inductor is 0. Remember this. Inductor does not allow sudden change of what current. For t0 plus, now the switch is open. Once the switch is open, this is the 1 ampere current source. Now this is the 100 ohm resistor, and this is the 1 Henry. Inductor. Now this 1 ampere current source will pass through the 100 ohm resistor. Why? Because this current is 0. Initially this current is 0. So what is the voltage across this point? V0 plus is nothing but 100 into 1, that is 100 volt. Initial voltage across the inductor is what? 100 volt. Right? Now, if it is 100 volt, second thing is what is the dV by dt. The voltage at this point is what V. You can write a KCL. So it will become what? 1 ampere. Current source is 1 ampere. Is equal to what? V by 100. I am writing the KCL. V by 100 plus current through the inductor. This is the IL. Now please differentiate it. When I am differentiating it, it will become 0. 1 by 100 dV by dt plus DIL by dt. DIL by dt. Then what is the dV by dt? dV by dt is equal to minus 100 DIL by dt. Minus 100 DIL by dt. So what is the value of the DIL by dt? Because we have the initial voltage across the inductor, this is nothing but V0 is nothing but inductor. We can find the value. Voltage across the inductor is given by L DIL by dt, 0 plus. What is the DI by dt 0 plus? VL 0 plus divided by what? Inductor. This is, what is the DL? Yes, 100. 100 divided by 1 Henry, this will become 100 ampere per second. That's why dV by dt 0 plus will become minus 100 into 100 minus 10,000 volt per second. Minus 10,000 volt per second. So Shruti Goyal, you are giving the 100 and minus 10,000. Absolutely correct. ये है आंसर B. So here this type of questions without use of what? Calculator. Without use of calculator, and you can solve all these questions within 1 minute or what? 1.5 minutes, right? तो आप आराम से 60 seconds और 90 seconds में इस questions को solve कर सकते हो. So this type of questions we may expect in what? Coming exams like what? BARC and HAL. Okay, and this topic transient is important, steady state analysis is important. Already I have given you the idea about the theorems, right? And if the dependent source is given, then how we can solve this type of questions. Time constant, how we can calculate the time constant in case of independent sources, or how we can calculate the time constant in case of what? Dependent sources. So already we have discussed number of questions. Now one thing. So that is what an inductor having a Q factor of 60 is connected in a series with a capacitor having a Q factor. So that is the assignment for you. In next class we will discuss this question. Assignment number 1 only for you. Please note this question. This is very important question. Inductor having the Q factor of 60 is connected in a series with the capacitor having the Q factor of 240. The overall Q factor of the circuit will be. So you are on BYJU'S Exam Prep, my dear students. Now we have session on 5th March by Rakesh Talreja sir and Asutosh Saxena sir. To please join that session. Complete strategy forward GATE 2023 and GATE 2024. Right? And please join please like the session, share the link of this session, and subscribe our channel. Thank you and good night. Okay, Ritik Gunjan, I will work on it.